All right, we're going to look at solving logarithmic equations. For the most part, these are going to be kind of set up in this format, this log base value equals exponent. If it is not in this format, we're going to turn it into this format for the most part. Our variable is going to be located in this value area, this value expression. So let's look at some problems and a couple of different approaches to solving them. So the first one doesn't show up a lot, but when it does, it's relevant, and that is you might have matching logs. Oops, sorry about that. Let's reset. Might have matching logs here. And so what we're going to do is we're just going to say, okay, these two statements are equal. I'm doing the natural log on both sides. That must mean that these expressions inside are also equal. So I'm just going to say this inside expression is going to equal the other inside expression. And then I'm just going to solve those problems. So add 2x to both sides. 6x minus 7 equals 5. Add 7 to both sides. 6x equals 12. Divided by 6. X equals 2. Maybe. X might be equal to 2. The thing we need to be worried about here is you don't want a negative inside of your logarithm. So when I take this x value, what I want to make sure is when I plug it in to these expressions in the original problem, I'm not getting a negative inside this logarithm. So 4 times 2 minus 7, 8 minus 7 is 1. That's okay. 5 minus 2 times 2, that's 5 minus 4. That's 1. That's okay as well. So 2 does work for this. If you get a negative inside, we're not going to count that as an answer for these problems. So be aware of that. So if you ever have a log equals the same type of log, this is how you go about solving it. More commonly, though, is a problem like this, where you're going to change it into the exponential form. You're going to put it in the log form if it's not in there already. So this problem, we're going to need to get this log base 5 of x minus 1 by itself first. So it looks like this. And then we're going to switch formats. So to get this by itself, I'm going to start by getting rid of the 2. Move that to the other side. Negative 3 log 5 of x minus 1 equals 4. Then I'm going to get rid of this negative 3 multiplier, divide both sides by negative 3. Log 5 of x minus 1 equals negative 4/3. And now I'm in my logarithmic form, and I'm going to change this to my exponential form. So my base is 5. My exponent is negative 4/3. Negative 4/3. And this is going to equal my value expression, in this case, x minus 1. Now I'm just going to solve this for x. So I'm going to add 1 to both sides of my equation. 5 to the negative 4/3 plus 1 equals x. You could change that to 1 over 5 to the 4/3 if you wanted to. Though this would be this 5 to the negative 4/3 plus 1. That would be good enough if you needed to put it in your calculator and get a decimal approximation. 5 to the negative 4 divided by 3. Close that up. Plus 1. And you could get that approximate value. Now, the reason why I want to get the approximate value is I have to be confident that this will not make the inside of my log negative or 0. And so this is a little bit bigger than 1. If I subtract 1 from it, it's still going to be bigger than 0, so it's okay. This does work as an answer here for this problem. And I would just leave it. You don't have to do the reciprocal of that number necessarily for this problem. And then another type of problem we would see here is where you have 2 logs. Maybe they're adding in this case, or maybe they're subtracting. And going back, we're going to, again, need to get it in this logarithmic expression, this log base of the value equals the exponent before we're ready to do anything else. So if you have two of these expressions, in this case they're adding, we can use that property that says if you're adding logs, you can combine those and multiply the inside parts. And now I have a log expression, and I can translate that. My base is 2, so 2 to the power of 3 equals what's inside here. So I'm just going to go ahead and distribute that out. Well, I'll just write it this way for now, and then we'll distribute it out in the next step. So this is going to be 8 equals x squared minus 7x. It's a quadratic. So I want to get it equal to 0. Bring that 8 over. And then I'm going to solve this problem. This does factor. This is x minus 8, x plus 1. So x could equal positive 8 or negative 1. Again, if I'm checking that, 8, that would make that positive. 8 minus 7, that would make that positive, so that's okay. Put negative 1 in here. Negative 1 doesn't work. So now, sometimes negatives will work. If you had, say, something like 7 minus x, a negative would be fine for that. So don't get in the habit of just saying, well, if the answer is negative, it's not going to work. You really have to look in what the log expressions actually are and see if it makes the inside part negative. All right, that's solving logarithmic equation.